Hello everyone. In this class, we are going to discussing about an important subtopic of testing of hypothesis is test of significance for single mean. Test of significance for single mean. This is the subtopic of testing of hypothesis. It says that suppose we want to test whether the given sample of size small n has been taken from a population with a mean mu. In this case, we set up the null hypothesis that there is no difference between sample mean x bar and population mean mu. In this case, we use the test statistic is means formula is the normal distribution, that is z is equals to x bar minus mu by sigma by root n. Here sigma indicates the standard deviation of the population. Sigma indicates the standard deviation of the population. Here one important note is if sigma is unknown, then we use another test of statistic formula, that is z is equals to x bar minus mu by s by root n. This formula is used only sigma is unknown, where s is the standard deviation of the sample. But remember, if sigma is unknown, then we use the test statistic, that is formula is not z, here t. So this is equals to the formula of t. Here s square is the, we know the formula for variance in samples. Sigma equals to 1 to n xi minus x bar by xi minus x bar whole square by n minus 1. This is the variance formula for sample, but here t is the t distribution with the degrees of freedom n minus 1. Okay. Now the definition is how to find the confidence interval. The confidence interval is to be find the confidence interval for the mean of the population corresponding to the given sample is given by the formula x bar plus z alpha into sigma by root n, comma x bar minus z alpha into sigma by root n. This is the confidence interval formula for the mean of the population corresponding to the sample. Here z alpha is the value corresponding to the confidence value or a value given value alpha. Here we have one note: null hypothesis can be taken or assumed in case of single mean as no difference, that is mu equals to mu naught. With the help of the above information, we are going to solve a problem here. According to the norms established for a mechanical aptitude test, person who are 18 years old have an average height of 73.2 with a standard deviation of 8.6. If 4 randomly selected persons of that age averaged 76.7, test the hypothesis mu equals to 73.2 against the alternative hypothesis mu greater than 73.2 at the 0.01 level of significance. Observe the given problem. Here 73.2, 8.6 are the mean and standard deviation of population. Here, average 76.7 is given for the sample, means that is the sample mean. Now we are going to test the hypothesis mu equals to 73.2 against the alternative hypothesis mu greater than 73.2 at the given level of significance 0.01. From the given problem, we have a data here 4 randomly selected persons. So 4 randomly selected persons means it can be treated as sample size n equals to 4, and here average height of the population is given, that is population mean mu equals to 73.2, and the standard deviation of the population is also given 8.6, but here average of the sample is given, that is x bar is 76.7, and standard deviation of the population is 8.6, that is sigma equals to 8.6. Okay, this is the data from the given problem. Now the steps involved to testing the hypothesis is, the first step is null hypothesis. Here given null hypothesis can be taken as mu equals to 73.2. Second step is alternative hypothesis is denoted by H1. It is also given in the given problem. Yes, alternative hypothesis is mu greater than 73.2, mu greater than 73.2. This is alternative hypothesis. Now the third step is the level of significance, always denoted by alpha. What is the level of significance is given is 0.01. This is 0.01. Now the fourth step is we write the formula, means test statistic is normal distribution formula is z is equals to x bar minus mu by sigma by root n. So substitute the required values in the formula. Here z is equals to x bar. What is the x bar value here? X bar value is 76.7 minus mu value is 73.2 by sigma value is 8.6 by root n value is 4. By simplifying this, the numerator value is 3.5 by 8.6 by 2. Now 3.5 into 2 by 8.6, this gives the value 0.814. 0.814. Therefore, z is equals to 0.814. Z is equals to 0.814. This equals to calculated value of z. This equals to the calculated value of z. Now, check the tabulated value or tabular value of z at the given level of significance 0.01. Now see the normal distribution table here. Check the 0.01 value in the body of this, corresponding to the row 2.3 and the column 0.03. So 0.01 occurs in the standard normal distribution table body part at the row 2.3 and at the column 0.03. By summing these two, we have the value 2.33. So this equals to the calculated value of z. It is denoted by z alpha. Okay. So Here we observe Z value is less than Z alpha. Z value is less than Z alpha. We conclude that we accept the null hypothesis. What is the null hypothesis is given is mu equals to 73.2 is true. Now there is another method is also there to solve the same problem here. All steps are same here. Null hypothesis, alternative hypothesis, given data is same. But in alternative hypothesis, we have mu greater than 73.2. Null hypothesis is H0 is mu equals to 73.2. Alternative hypothesis mu greater than 73.2. Greater than means it is right tail test. So level of significance is also given, that is 0.01. So in alternative hypothesis there is right tail test is given. Why? Because there is greater than symbol, that's why there is right tail test. In right tail test or left tail test, level of significance can also be taken as alpha 1 equals to 1 minus alpha. 1 minus alpha means the given value. Alpha 1 is the calculated value here, that is 1 minus 0.01, that is 0.99. So the fourth step is a test of statistic, means formula is same, it has the value 0.814. 0.814. All steps are same in the like above process. It is calculated value, but only one difference is level of significance can be calculated in another way here. Now check the 0.99 value in the standard normal distribution table, body part. Yes, 0.9901 is there, which is near to 0.99. It occurs at 2.3 row in the column 0.03. So the 2.3 plus 0.03, that is equals to 2.33. Okay. Here by using the same process here also as above, Z alpha is the tabular value 2.33. So observe Z is less than Z alpha. So Z value is less than Z alpha value. That's why we conclude that we accept the given null hypothesis. Okay. Null hypothesis. So this is the same process as discussed in the above process also, but only difference is level of significance.